11.3, probably about multiple events. So first thing we have to talk about is if we have independent or dependent events. So dependent means that one depends on the other. Dependent, one depends on the other. Independent means there's nothing in common, like you're an independent person. You stand by yourself. So first you have to decide if one depends on the other. So you roll a number cube and then you spin a spinner. There's nothing overlapping there. These are independent events. Pick one flashcard, then another from the same deck. Now this is careful. It's saying you have a deck of cards, you take out a card, you flip that over, and then you take out another card. That means that the total changed. Once the total of the pack or of anything changes, that's a dependent event. So do C by yourself. Now to find probability with two independent events will both occur, multiply the two events together. So at a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what's the probability you will get a diet drink and fat-free chips? So first we have to try to figure out our totals. So when I'm talking about the drinks, remember the total always goes on bottom. There's a total of 15 drinks. And it's asking what's the probability you will get a diet drink. There's a total of 10 diet drinks. Okay, so these are independent events because the drinks and chips do not have anything in common. And then, so whenever you hear the word and with probability, that's always going to be multiplying. What's the probability you would pick? There's a total of 20 bags of chips. And you're asking what's the probability you pick a fat-free. So now we multiply the diet with the fat-free. And you could have your answer as either 4 over 15, or if you do it as a percent, that would be 27% chance. Now I want you to try to do what's the probability of getting a regular drink and regular chips. So now the other information we have would be mutually exclusive. So saying that the two events that cannot happen at the same time are definitely mutually exclusive. There's no probability that having them together, having a combo of the situation would be 0. So if I have a number cube, rolling a 2 and a 3. Well, when you roll a number cube, you only get one number. So these would be mutually exclusive. Me. Because there's no number on the number cube that's a 2 and a 3. So rolling an even number and a multiple of 3. So this is not mutually exclusive. Now, one way you can try to think about this is there a situation where both of these go together? Well, yes. You could roll a 6. A 6 is both even and it's a multiple of 3, so that would be not mutually exclusive. So you try C and D. So when we see or, we're always adding. However, you have to be careful, because if we said an even number and, so or should be adding, or a multiple of 3, you can't add them together without subtracting where they overlap. So if it's not mutually exclusive, you must subtract where they overlap. So at your high school, a student can take a foreign language each term. 37 of the students take Spanish. So 37 is Spanish. And 15 take French. What's the probability a person is taking Spanish or French? Well, 2 key things. It says that you can only take one foreign language, so there's no overlapping. So these are mutually exclusive. And since these are mutually exclusive, you just have to add them together. Or you should always add. Or is add. So that becomes 52%. So you do B by yourself. Suppose you reach into a dish and select a token at random. So before I do this, I'm going to count up the totals. Now, I just did the shapes first. So what's the probability that the token is round or green? So first I'm going to look at the probability it's round. So I have 1, 2, 3, 4, 5. There's 5 rounds. There's a total of 9 here. So I would have 5 over 9. That's round. Or, so I add probability that it would be green. I have 1, 2, 3, green. So I'm adding the 3 green, so 3 out of 9. Now this is where, because they're not mutually exclusive, you have to subtract. What are we subtracting? We're subtracting where these two lie together. So that would be green and round. I have 2 that were green and round. So I subtract 2 out of 9. Now this is one way you could do this. So this becomes 6 out of 9, or else that's the same thing as 2/3. One thing you could go is round or green. So if I had this piece of paper, I could go, here's green, 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 here's round, 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 and then I could add up all the ones that I make a tick mark. We counted some of these twice. We counted these 2 twice. That's why we had to subtract them. So if I just make the tick mark, that was 1, 2, 3, 4, 5, 6, and that's another way that you could do this. So I want you to try B and C by yourself. And then once you do B and C by yourself, I just want to say thanks. Thanks for being you, and thanks for being awesome. And have a great day.